Hi, my name is Jignesh and I'm from Canopus. Welcome to Flutter Zero to Hero series part 3. In previous tutorials, we had a look at some of the Flutter basics and we implemented this onboarding screen, and then we had a look at Flutter navigation and we implemented this phone authentication, and it kind of works. And today we'll try to clean these things up before we add more screens. If you see our implementation, then you will notice that almost everything is on in the same file, right? This main.dart file, and this is not maintainable in the long run because going ahead we'll add more and more screens. So today we'll see how to structure our app, like what kind of architecture or packaging things we can use, so that it's scalable as we add more and more screens. And yeah, once that is done, then we'll also see Flutter state management. In that we'll explore block and Riverpod, and then we'll see some of the tricks and tips for using MVVM architecture in Flutter. So uh, yeah, let's get started with this without wasting our time. So we have this main.dart file here, right? And what we want is that, like, this file's responsibility should only be something like running this app and nothing else. So we'll do that. What we'll do is, like, we'll move everything else into their own files as per the need. And for that, we'll have to do some kind of architecture we'll have to make some kind of architecture decisions, because what happens is, like, most of the apps I have seen, like, those apps use two kind of strategies. One is that either they package by layer, and another is like they package by feature. So the difference between two is that in package by layer, what they do is, they kind of create a few folders, and each in each folder, like, they only put those kind of items. Like, suppose inside the lib I create one UI folder, or one folder for view model and one folder for repository, and then I put all the 100 repositories in the same folder. And the same is true for the screens or view models or whatever there is. Basically, they are grouping the files based on its content type. And another is package by feature. That is, like, if you have a huge app, right, then if you do package by layer, then you'll have so many files in a single folder, and you have no idea, like, if you wanted to edit a screen or implement something, then where you will have to make those edits. So for that, the package by feature is there, where I can create a directory for authentication, and I can put all the authentication related files inside a single directory. And the same is true for, like, onboarding or home screen and etc. So what I personally like is kind of mix between two, where at the root layer we kind of divide everything by package by layer. Like, we can create two root directory. One is for UI and another is for data, like storing the respective files. And then inside that we can package by feature, right? Like, inside the UI we can have directories like auth, onboarding, home, and like whatever is needed. And the same is true for data. What this will allow us to do is that it will keep things separate. And going forward, like, if your app becomes too huge, then you can move that data folder and create a separate module for that. So yeah, that offers a lot of flexibility, and it's also kind of scalable. Like, for this medium kind of application where you have around 100 screens or something, this works like fine. And that's what being used in our open source repository as well. So you can have a look at that as well. And so yeah, let's get started. Okay. if we open this main.dart file, then this is the thing we want to keep, right? The next is router. So what we'll do is we'll move that router file to its own this router implementation in its own file. And for that, as I talked about earlier, we'll create one UI directory, and inside that we'll create this file router.dart. Okay, and now let's move this router implementation into its own file, that is here. And I'll make this public variable. So in Flutter, every variable that starts with an underscore is a private variable, and that can be accessed only inside that file. So as we want to access this variable outside, I have made it public. And now I can just update the import here, and it should be fine. If I run the app, then yeah, it works. Okay, now what we have is this my app, and this also should be inside its own file, I think. And so for that, we'll create another file called app, and I can move that widget inside the app file. And yeah, I think that's everything. I'll just have to import app here again because the path is different now. And yeah, if I run the app, then it works fine. Okay, so yeah, we were able to successfully move these two into its own file. You might be wondering, why we are doing this, right? Like, this app has only like kind of 5 lines of code, then what's the meaning of doing that? But that's because our app is really really small now. It has only 3 screens, and going forward, as we implement too many things that are common across the app, we'll need to put that here. Okay, suppose we want to have a different theme for Cupertino and also the Android, then we'll have to put that logic here. And similar way, yeah, anything that is like that you want to apply throughout the app will go here. And so this will kind of keep growing, and it's better if we take care of that right now. And the same is true for router. We currently have only 4 screens, but um, we'll have more and more screens added here going forward. So that's the reason of that separation. And now in UI, like, this looks fine, and it's time to start moving screens. And so for that, what we'll do is we'll create one file for each screen, but we'll also group them by feature. Okay, so this onboarding will go into its own folder. I'm calling it onboarding folder, and inside that we'll create a file onboarding dot underscore screen. And we can move our code there. Okay, and we'll need to import few things. And yeah, it looks fine. Now we'll need to implement update the import here in router.dart file. And if I run there, then it works fine. Now let's go back to this onboarding screen once. You see, we have 12 warnings here, right? These warnings are never good. We want to fix them as early as possible. Those are kind of some suggestions by Flutter that this is how you can improve your code. Okay, so let's have a look at that. When you click on that, you will see yeah, what you can improve. So first thing, yeah, and you can also notice that here, if you have warning, then you will see these kind of lines, and yeah, yellow lines. So you will notice some warnings. Okay, so the first we have is use a size box to add a white space to a layout. So we have used container here, right? And if you see here, then the container's job is to only add width in this column. And like Flutter is kind of correct here, like it's saying that you shouldn't use container here, and instead of that you can just use size box. That is a lighter widget, so it will be easier for Flutter to draw it out, and it can improve some performance. Okay, so yeah, we replace that container with size box, and that is one thing you will see going forward. Like container offers lots of things, like if you want to add padding, that is also available. If you want to add size, that is also available. But you should not use container if you just want to add padding, right? If you want padding, then you should use this specific widget that is added for padding, instead of using container for padding. And that's the mistake we made here. Like for sizing, the size box is the widget we should use, but we use that container, so that's why the warning was there. Now let's see other one. Use constant with the constructor to improve performance. So this is a warning that you will get again and again. If you have some part of your code that never changes, then there are some optimizations that Flutter can apply if you use a constant keyword. That means, like, if something is constant, like you see here this object, right? This object never changes, and that's why Flutter, under the hood, Flutter can do some optimizations, and that's why it's advising us to add a constant keywords wherever like objects are like not changing at all. So what we do is we select this add constant modifiers everywhere in file, and it will edit everywhere in the code, and all the warnings are gone. Okay, so yeah, keep an eye on warning and make sure that we fix them as needed. Now if we go to main.dart file, then we have this auth related screens. So what we'll do is, as we are grouping by feature inside the layer, we'll create a new directory here called auth, and inside that we'll put these two screens. Okay, this auth phone screen and auth OTP screen. So we'll need to create two files here. I'll create first one, auth phone screen. Okay, and another is on auth OTP screen. So yeah, those are added, and let me now move these classes. So if you notice, then this is a stateful widget, right? So we'll have to move these two classes into that file instead of just one, as here we have one for screen and one for state. So let me move these to auth phone screen, and then yeah, obviously we'll need to make some imports. But if we do that, then I think we'll be kind of done. Let's see. And yeah, if I there's still this error because I need to update the import here, and yeah, I did that, and now if I run the app, then it works fine. Okay, now let's go to this auth phone screen and also fix the warnings that we have. If I click on that, then yeah, obviously the first one is this constant that we already discussed, so I did that. And then yeah, we also have a constant warning there. And then we have this don't invoke print in production code. This is like really true, like we shouldn't be printing in the production, but here we have added it just for demonstration, so let's keep it for now. Now we'll move the content of auth OTP screen widget here. So let's go to main.dart file, and I can move the content there. Okay, we have two errors here. One import is missing here, and this last one that. Okay, so yeah, everything is sorted out now, and if we have a look at warning, then yeah, obviously this constant is there, so let's first fix that. And then we have this print that we can ignore. Another one we have is this build context. Don't use build context across async gaps. So what does that mean? If you see the code here, then what happens is, like, on button press, we call this is a synchronous method. That means like it returns immediately, and it does not take any time. And this one is kind of async method. That means that it gets executed asynchronously, and it can return at later point of time, right? So if I press this button and suppose this takes 2 seconds, then for 2 seconds, like, this flow will be freezed here. And during that time, user might close the app, or this widget might be in, like, unmounted, or might not even be on the screen, right? So what it's saying is that if you shouldn't use async, I mean the context after async gaps. And if we want to use, then we need to verify that this context is mounted. Okay, if you add this, then this error will go away. That means, like, we are checking that this widget is mounted before we use its context, right? And that is the right thing to do, because what happens is, like, suppose user press the button and then they pop the screen while the login is in progress, then user might be on another screen, but at that point this will get executed, and we certainly don't want to call this on our router at that point. So yeah, that's that one. Another one we have is this class is marked as immutable, but one or more of its instance fields are not final. So if you have a look at this class, then we have this auth OTP screen class. Inside that we have this OTP field that is not final, because what happens is, like, we are changing its value when user is typing, right? When user is typing, we are just updating its value. The reason we did that is, we are not actually displaying this new OTP value anywhere else, right? So we didn't have a need of refreshing the UI, and that's why we didn't need that stateful widget, and we ended up defining this one. um, but yeah, this is not right thing to do, and we'll actually fix this when we implement state management. So for now, it's safe to ignore this warning. But the lesson is that if you have stateless widget, then you should not have a variable that keeps changing. You should have only final variables. Okay, so now I can go to router file and I can update the import, and if I run the app, then yeah, it's working fine. Okay, now let's go to main.dart file. We have this home screen. Let's take care of that as well, as we are grouping by package there, feature there. I have created a home directory inside UI, and inside home directory I'll create home underscore screen file, and I'll move this content here. So let me do that, and should be very simple thing to do. And yeah, so yeah, if I run the app now, then it will work fine. Now if we have a look at main.dart file, then we have this main function, but we have these two constant variables. Okay, so what do we do about that? Whenever you have a constant that you need to maybe reuse or don't need to reuse, it's better if you give a thought, where should I put this. Lots of beginner developers, what they do is they kind of put this inside a global file called constants.dart, or whatever, constants.java, like, depending on the platform, they'll just define one file and will put all the variables there. That is not a good thing to do, because as your app grows, you'll have maybe hundreds of variables inside a file, and you have no idea, like, changing the value of what changing the value of what kind of effect will have if you change value of any variable. So it's better to decide, like what's the use of this variable. Okay, like if we have a look at these two variables, then these are kind of app level variable where they are responsible for deciding the color of the app, right? So it's better if we put it somewhere around app, right? And that means, like, for now we can put it in app.dart file, and that is, the context of these variables. Like, you should always put variables nearby. Like, suppose I have some variable that are that's needed in the auth screen, right? Then by default I should only put it in this file and not in app.dart file. But if I have variable that is used inside only these two files, then maybe I can define it in one of the files, or I can create a new file here just for those variables. So yeah, basically keep the variables as close as possible to, like, those related entities. And yeah, now of course, as we change the location of those variables, we'll need to update our import, and can do that very easily. Okay, so that's fixed. And if I run the app, then yeah, everything works fine. And here we are basically done with the cleanup. Like, this is kind of architecture we'll use going forward for storing our files. And one of the things that you need to keep in mind is that, everyone has different opinions. Like, the architecture I'm following for storing the files or packaging the files might not be the one preferred by you, but that's not the main, that doesn't matter. What really matters is that, whatever you or your team decide, be consistent with that, right? That will help, future developers to find those files easily when they start making changes. And those future developers might be you only if you open your project after, 3 or 4 months, because you'll have no idea like what's going on, even though you were the one who wrote that code. So yeah, be consistent with, like, whatever rules you or your team defines. It's better if you do a small meetings and let everyone know. But it's even better if you just create a shareable doc, and yeah, define the rules there and let everyone know about those rules. And if in future anyone joins, then yeah, please like, make them aware about those rules. So your code will be consistent. Consistency matters, and not some of the decisions. Like, whatever package type or naming type, like whatever you choose, be consistent with that throughout the code. Okay, so yeah, for now in this repository we'll follow this kind of architecture for packaging our files and naming our files. Okay, and if we go in this test directory, then we are getting an error here, because we have updated location of this my file. So I can just update the path, and that's fixed as well. So yeah, now we are done with packaging the app in correct way, and everything looks really clean now. Okay, so we are done with the cleanup and yeah, packaging our files properly. The next thing we want to do is, we have these files, like the first complex screen that we have is this auth phone screen. And if we have a look at file, then it is kind of mix of two. Like, we have UI specific code here, but at the same time we also have all the business logic in the same file. So that's the one thing we want to address next. And for that, Flutter has some concept, like, how you can separate the business logic from UI. And yeah, so let's have a look at a few things. Like, the first thing we can search is, Flutter state management. and I will have a list of, yeah, a list of approach that we can use. um, like there are many I would say good approaches, and none of them is bad. All are good. Just whatever you use, you need to use it properly. um, Today we will explore this Riverpod, which is pretty famous. We already had a look at how we can do it with set state kind of, right, like having everything in the same widget. But yeah, and we'll also have a look at block architecture. We'll actually first have a look at block, and then we'll see how we can do it with Riverpod. Um, if we have a look at abstract concept of these things, then these are all similar, where they are just trying to you know separate the business logic of the UI from from the UI itself. So what happens is, like, if you have your business logic separate, then you'll be able to write some really good test, like unit test, and then you'll be able to verify that logic, and that will also be less error prone and maintainable, because you have UI different place compared to business logic. And then UI will be kind of just a state of data, and this is explained pretty well in Flutter architecture. Like, if you go down here, then you will see that at the end, Flutter works like this. Like, you cannot create UI imperatively in Flutter. It's basically reflection of your data, and you need to define some rules. Like, if my data is like this, then my UI should be like this. If my data has this variable, then show this UI. And after that point, once you have those rules defined in your widget, then you can just start writing how you control the data. And that is basically the state. This data state is here, and UI is basically function of that state, right? That's what we'll do. We'll try to separate this UI and the state that we have. So the first approach that we'll have a look at is this block architecture. um, it is a really good library. You can actually implement block architecture without this library as well, but we'll see how we can do it using this library today. So if you have a look at library, then you'll need to understand a few basic things. The one thing is qubit, okay, and another is block, and then you'll have block provider. So let's start from the basic. Let's follow the doc. I think they have like really good documentation. um, yeah, we'll go to core concept. So if we have a look at qubit, then qubit is basically something that is created, um, that is very specifically created for this UI. And what happens is, like, then UI will be just reflection of that state. And then, like, whenever that UI needs to be changed, at that point, like, some of the functions on qubit will get called, and that will again modify state, and that will update UI. So that's basically the cycle here. And then qubit can have access to the data layer and all, to manage its own state. What happens is, like, suppose you have a long list of users that you want to sometimes fetch from database, and want to fetch from the APIs as well, right? In that case, what will happen is, like, qubit will fetch those data combined from database and API, and will store it as a state. And then UI will just reflect that in the list. So and if suppose we have a delete button in the list item, and then, yeah, whenever the delete button gets clicked, then this UI will invoke one of the function on this qubit, and that qubit will delete that item from the list and will update its state again, and according to that UI will be updated. Like basically this is the state I was talking about, and this is the reflection of that state, that is basically UI. So creating a qubit is really simple thing. Okay, a qubit holds a state and that you need to provide as a argument here. Like you see here, this is a generic class, so you know in bracket you need to provide integer, so this qubit will only store an integer, and yeah, that's it. And then you can have some methods in the qubit as well that can, you know, increase, or I mean that can modify its state. Like, you know, here we have this increment method that says that emit and then like state plus one. So the state variable is basically the current state of the qubit, right? What we are doing is like we are doing state plus one, so we are incrementing its value and we are calling emit function with that. So emit, whatever, whenever you call emit with any value, then that becomes updated state. So what happens is like state will be incremented by one, and next time you access the state of this qubit, then it will have plus one value. And yeah, the usage is really simple. This is pure Dart usage, as this is not a Flutter library, it's a pure block library. So you create a qubit, you access its state, and it will have its own initial value, right, that we provided as 0. So yeah, here it will be 0, and then you call this increment function, and then you check its state, and yeah, it will have plus one value, and then you can, you know, delete, I mean close the qubit. So yeah, there are, you know, these methods that you can use, and then we have a callback on change. I'm not sure, like depending on your situation you might need this, but it will not be necessary in today's tutorial, at least. Like if you want to observe this qubit state change and want to do something, you know, like you here we have only one increment function, right? But on state you might have so many, like, you know, decrement, increment, multiply, and also whenever all those functions change the value and you want to do something that is common across all of them, or maybe just print the change, then yeah, you can do it that way. So that is one qubit is a very important thing in block architecture. And if we talk about the screen that we have here, right, then we can have a separate qubit for, you know, holding the state of this country code, and then we can have another one for this phone number. So like what we have here is that we have these two variables, we can kind of get rid of that, right? So let's try to do that. Let me first install the library, this Flutter Bloc, and let me go to install, and yeah, I might already have added. No, I haven't added that. Yeah, so it's added now. And now what we'll do is, for now we'll define that qubit in the same file. Okay, I'll call it auth phone number, or auth phone country qubit. Okay, and then it will extend qubit and country code. I'll make import here, and yeah, that this is all we need. Basically that value will be null by default, and whenever this method is called, it will set that as a state. Okay, another class we need is auth phone um, number qubit, because we'll store our number here, and yeah, basically this GitHub Copilot kind of gives me the exact thing I want. But I don't want to make this optional. By default the phone number is empty, and I want to represent that as an empty string. So Yeah, I think these are the two qubits. So let's see how we can use that. Okay, first of all, we'll get rid of this thing, and we'll actually convert this class to um, stateful widget, not stateful but stateless widget. Okay, actually let's do that later. First let's see how we can start using this qubit, and then at later point we'll convert the widget and we'll see if that works. Okay, so if we see the docs, like we have qubit now, right? But how do we start using that? And for that we'll have to use something like, block provider. What happens is, like, we have our own this qubit classes, but somehow we need to provide it, and then at one point we'll have to interact with that, right? Like when in UI we need to read its value, and when user types something, or they mm, select something from the country picker, then we need to update its value as well, the country picker value. So at that point we'll need to call this method on this qubit. So two steps: one is like how we can provide the qubit so it's accessible throughout the UI, right? So for that we have something called block provider. Okay, and in that we'll have this create method, and in that we need to provide the qubit, and as a child we can provide our widget. Okay, and this is fine, this should work, but the only catch is that we have two qubits, right? So how do we provide two qubits? Because we only this block provider, if you have a look at its method, then this create allows you to specify only one qubit, right? And that means you can only provide one qubit here. So like there are certain ways to do that, but let's see how we can do it very easily. Like we can wrap this block provider into another block provider, right? Okay, and then here we can provide our phone number qubit, and this should work fine. Block provider, if you go here, then you'll see that we have this block provider, and yeah, you can basically create your block here or qubit, and then as a child you can provide your widget that will have access to um, the qubit state that is provided. Okay, very very simple thing to do, and let's see now how we can read the value of that qubit state, right? Because that's also one of the basic things we'll need to do. So if you have a look at their example, then what they say is like you'll need this block provider. Like first of all you'll need a qubit that we already did. We also added this block provider, and then um, yeah, we can read its value with something like context dot read, and then um, we can, so this will have a variable called state that we can use. So let's do that. So there are two things. One is reading the state, and another is like how we can mutate that state, right? For that, we'll need to call method on that, and so that is we'll do. Um, Actually, let's do that first. Okay, we have this country code picker, right? Inside that we have this on change, and like GitHub Copilot is already suggesting that we call this context dot read, and we provide our qubit class here and call that method, and that will basically give us that qubit, right? If I separate this sentence just for readability, then you will get idea. Like we first get qubit, and then we call this method on that, and if you go to this method, then that will just update its state to have this new value. So That is how we can call methods on the qubit. But another part is like how we can read the state of that qubit, right? We'll also see that, but let's first yeah, also use qubit here. So now we are done with that, and now what we need to do is we need to read its state. So I talked about that earlier, like that qubit have this state property. And if you see here this increment, then you can already see that inside the class also you can access that, and inside the emit they have used this state +1. That means like this is the current value, and then they are just incrementing that, and you can read that outside as well. So here we have use country code, and then after that we use this phone number. We just read both state, and as now we have phone number by default empty. Yeah, if country code is not selected or phone number is empty, then just return. And those are, I think, all the changes that we'll need in order to um, move to block architecture. If I run the app now, and if I see, then let's see if we get any error. Okay, yeah, we definitely get one error. Let's see what that is. um, could not find correct provider auth phone number qubit above this phone auth phone screen widget. So what happens is like um, when we type something, this method gets called, okay, on change, and in that we are trying to read the qubit. Pay attention to how we are reading that value. Okay, we are trying to read it from this context, right? And where that context comes from, let's see, it's basically passed as an argument in this country code. And this country code, let's see where that context value comes from. It comes and as an argument in this body, and inside the, if we check this, then it basically is provided in this build method, right? That means it comes from the root widget of the screen. And even though we have provided our you know block, we have added block provider here, that context we are not using. We somehow need to use context that is of a widget inside this block provider. So what happens is like currently we are using context that is outside of that block provider, and that's why it is not injected, it does not have this injected block providers. Okay, I mean it does not have this qubit, right? Because it's injected from this widget onwards. So what we can do is like we can add one builder here. Okay, builder will basically have this context as an argument, and after that this context will be child of this context is provided by a widget that is child of this block provider, right? That means this context will have these two qubits injected. So let's now try to run this and see if it works, and let's also see the error. Yeah, it's not throwing any error. And if we print something here, like um, just to observe things whether it's being called or not, yeah, it's working fine. Okay, another thing is that, I mean, like, you need to be very careful with the context. I have seen like beginner developers making so many mistakes related to context, right? Because context, all the widgets have its own context, and that's why sometimes you are using a widget that is not part of a widget hierarchy, and you are trying to access something like in this one only, like this context has something called uh, padding and all those property, right? So we have added this safe area, and that means it will add a few media query padding and all. um, like we can have media query dot of context, and that can have a padding, right? So it can have, system and system inside padding and all. So what happens is, like, suppose you are trying to, in get the bottom inside, right? So um, you call something like view insets or view padding, and you use a context that is not created inside the safe area. So what happens is, like, um, when what you expect is that, like, if I try to use this top inset, then as I'm inside the safe area, I'll get this value, right? But that will not happen if you don't have this builder. Okay, let me actually try to separate that, so it's easier to understand. So, like, inside the block provider we have safe area, inside that we have builder. But suppose we didn't have this builder, okay? In that case, like, if you try to access this media query, then it will not have this padding, even though it's inside the safe area, because the context that you are using is not part, I mean, is not of a widget that is part of the safe area. So yeah, whenever you apply something that is that can inject some values into context, then you need to have, like, you need to use a context that is created inside this widget and not the parent widget. So yeah, that's just one thing I wanted to highlight, because so many developers make mistake in that area. Context matters, but where that context comes from, that matters even more. um, so yeah, we have phone number and this country code now, and it's fine. And let's try to move this into its own file. Okay, I'll call it auth form qubit, and I'll move it there. I'll have to make some import. Okay, can remove this print now, and I'll have to again make some import here. But yeah, we are done here. Okay, and if I run there, then it's working fine. The next thing we want to do is, like, we have separated state from the UI, but it's not entirely separated. Like, we have this business logic here, right? Like, what happens when you click on this get OTP button. So for that, like, what we need is something that will process the business logic of this screen, right? And like, we have two qubits here, right? And I'm not sure, like, where I should add that, right? And wherever I add it, I'll also need value of these two qubits. So I think instead of having two qubits, what I can do is I can create a class called auth phone state. Okay, and I can add these two variables as a value here. Okay, I'll call it country code, and then another is phone number. Okay, and yeah, this is very simple, right? mm. And then what I can do is, like, instead of two qubits, I can have only one qubit, like, for this screen auth phone qubit. And as a state, I'll use this auth phone state. Okay, and basically this you know GitHub Copilot has added things, but I want to remove that, so it will look clear. So as you can see here, like, I can also make this optional. Okay, so by default, if no values are provided, then yeah, it will take null value. And yeah, if you see here, then this is a really simple qubit which has auth phone state as a state instead of just integer or string or that country code we had. So we now have this entire screen state inside this class, and we have one qubit to hold that. Okay, and now we can add some method that will basically mutate the state that we earlier had in two different qubits, right? One for setting the country code and another is for setting the phone number. So for that, what we'll need to do is that, um, we'll need to, so let's try to define that method. Okay, what we want to do is, like, when this is set, we want to broadcast a new state inside the emit that will have this new country code value, right? But as you can see, we don't, like, if we want to do it manually, then we'll have to do something like this every time. Well, I'll use the provided country code value and previous phone number value, right? And the same thing is true for the set phone number. But there is a shortcut of doing that. What I want is, like, when setting the country code, I want to take previous value, copy it, and only modify the country code, right? And the same is true for the phone number, where I take the previous state and I just modify its phone number value. So what we can do is, like, we can create a copy with method, okay? And that will basically, what it will do is, like, it will have two parameters, country code and phone number. Both are optional, and whatever is provided, it will take that, and otherwise it will use the current state, right? That is exactly like what we need. So here now, this will become really simple. I can call something like state dot copy with, okay, and inside that I can have this country code, and I can do the same for the phone number as well, okay. Like, this makes thing really simple. And if you are not familiar with this concept, then it's also mostly used in data classes, where instead of modifying the state of an object, you create a new object of the same class with the new value. So, if someone is holding on to a previous object, they will never, have to deal with that mutation. Only the new object of that class will have that updated value. So yeah, that is basically something called immutability, and yeah, you can have immutable classes. Mm. So this looks all set now. Now we'll need to, yeah, one thing I forgot to mention here is that, in this block provider, we have this nested block provider, right? But block library offers something called multi-block provider. There we can, instead of nesting this block provider, we can have something like multi-block provider, and inside that you can define all the providers and provide a single child that will have access to all the providers that you have listed. So yeah, I'm not I'm not using it here, but yeah, this is something you should definitely use if you have multiple block providers. But before that, even that, before that, you should try to move your screen state into a single state class, and you should have one qubit, with that state. But if you have really complex screen, and you are sure that you need to deal with 3 or 4 different state for this screen, then yeah, in that case you can use this multi-block provider. So now what we'll have here is auth phone qubit, and yeah, we can get rid of this another nested provider, I mean qubit, and here we'll have auth phone qubit. So we'll get qubit, and inside that we have this country code. Same thing, no changes needed there. Okay. The change we'll have is this one, because earlier what happened is, like, we had separate qubits for each value, right? So if we access the state, then it already had this country code value, right? And the same is true for this phone number qubit. We directly got phone number with the state field. But now, as we have the state a different class, and inside that we have two fields, right? Country code and phone number. So yeah, we'll need to make that change here, and use the fields instead of just the state. Okay. um, I think that's everything now, and if I run the app, then it should work fine. Let me actually see if it's working fine. I can print. um, yeah, we still have that you are reading. Okay, maybe I didn't rerun the app. Let's see. Because sometimes when you add this kind of dependency, even if you do hot reload, then you will get the same error. So in that case, just rerun the app entirely and see if it fixes the issue. It was giving an error like it cannot access the font qubit from that context, but ideally with the code we have, it should work fine. So let's see. It's still running. Not sure why it's taking too much time. Let me rerun that. Yes, somehow it's not running the app in here. Maybe if this doesn't work, then I'll restart the simulator. Uh, but yeah, while it's running, yeah, it's working fine now. Let's see. Okay, it's still giving error. Uh, could not find the correct provider auth font state above the builder widget. Sure if we are using stale context anyway. We have block provider here where we create this auth font qubit which has auth font state, and let's see what we do here. Auth font state, where does this context come from? Ideally it should work fine. Okay, so error we had is that here we are directly accessing state. Instead, while reading, we need to use the qubit class, and then it will have the state. So that's why it was trying to access incorrect class, and that threw the error. But if I run this now, then yeah, I'll be able to run these things. Yeah, it's working fine, and yeah, I get redirected on that screen. So that is fine, but still we have this logic inside the UI, right? That's not what we want. So now it's easy thing to do. What we'll call is something like set verification, or we have state here, right? So we can create something like on submit, and then we can move this logic there. Okay, and we already have state here, right? So we don't need all these things. yeah, we'll need to make import for this. And yeah, everything works fine, and I can make the on submit call on this qubit. The only error we have is that on code send we used to redirect users to the OTP screen through this context, right? And that context was accessible because this code was inside the UI. But here we don't have that, right? So somehow once we get this verification ID, we'll need to pass that back to UI, and UI will need to listen to that. So we can do that easily by adding a variable called verification ID here, and by default it will be null, and yeah, I'll need to add it in the copy with as well. Okay, and then what happens is, like, once this code sends successfully, at that point we'll broadcast a new state that has this verification ID. Okay, so that's what we'll do from qubit, and I think that's the only business logic we need here. And then somehow we'll need to observe that in UI, and when that happens, we'll call this router push method to push the new screen. So let's see how we can do that with Flutter Bloc. We'll need to use something called block listener that allows us to listen to something as a side effect. Like, I just want to listen to this thing in UI, and that's it. It will not add any widget or anything. I can just listen to the state change, and then if I want to take any action, like when this value changes, or when this verification ID is sent, then I want to redirect users to the new screen. So that's we can do easily with the block listener. And if we see the details, then it's a very simple widget that has a callback called listener. Inside that we get state every time it's updated, and we need to define our widgets as a child. So yeah, very simple thing. We just need to like wrap our widget with this block listener. And if you see here, then it's a generic class, and it has two parameters. One is this qubit itself, and another is its state class. So let's do that. If we go to our code, then we have our block provider here. So you must define this block listener as a child of the provider, otherwise it will not have access to the qubit. So here we can do that. We can have block listener, and we can have the listener callback, and yeah, here we'll get that callback whenever a value is changed, but we are interested only the change when verification ID is not null, right? Because at that point we'll need to make that redirection. So that we can do easily by checking state dot verification ID is not equal to null, and yeah, we forgot to specify our generic parameters. So here we have qubit, and here we have the state. So yeah, and now yeah, I can just check the auth. This verification ID is not null, then we want to call this go method, and yeah, this copilot has basically autofilled the code that I instead of that I should have written. Basically we are passing the values, and if you see here, then that's all we needed. And now we can remove. Actually we were pushing the screen, so that's what we should do here, and not go, but push. I have already explained what's difference between that in the first episode of this series. So yeah, now we will just set the state here, and then screen is listening to state changes. When verification ID is not null, we'll push the screen, and that will that will be it. So now let's try to run this and see what happens. I'll set phone number, and I'll also observe logs. Ideally it should work fine, and yeah, it's working fine, right? On code sent, we were redirected to the screen, but now if we have a look, if we have a look at this screen, then it's all clean. It does not have any business logic, and it's basically reacting to the changes that are being done in this qubit. Okay, and if any user input is there, then it just pass those values here, and then this qubit is actually responsible for changing the state. So now if we wanted to, then we can write some unit test here to verify that we don't regress in future. We'll actually do that in future part of the series, but yeah, this is how it works, and this is block architecture. And yeah, we have refactored our screen using block architecture. So that is it for block architecture. Now I'll demonstrate how you can do this using Riverpod. Okay, so we'll first go to library page of the Riverpod, and we'll click on get started. So Riverpod is, like, I will say, very similar to this block architecture that we have used, but there will be just syntax differences, like how in block we had to create a qubit and then we had to access it, right? And with Riverpod we'll have to create something else, and then we'll have to access it somehow. So that's the only difference you will see. And to begin with, Riverpod is available as two type of varieties, in two type of varieties. One is with this code generation, which is a new thing, and another is like without code generation, and that was what we had earlier. So there are some differences, and with code generation, what happens is, like, you'll have a few shorter functions to define in order to use the state. And without code generation, you'll have to write some extra things, like we have code generation turned on, and you see here we have this annotation, and based on this annotation we directly get a Riverpod that is equivalent of a qubit in the block architecture. So in the Khelo Flutter open source app, we have used it without code generation, and we'll use it in the same way today. So yeah, let's get started with that. Okay. The first thing we need to do is, like, we need to add this dependency. There are two dependency, actually only one. You can add this lint dependency if you want to check, if you want to add some lint check. But yeah, for now today I will add this Riverpod dependency, and we'll call pubget. And yeah, and if you wanted to verify some syntax related to Riverpod and catch some issues during lint phase, then you can add this dev dependency, and you can also add this in plugins custom lint. And yeah, basically there are some configurations that you can make related to that, but yeah, we'll skip that today, and we'll start here. Okay, so this is the first change that you will see inside the run app. Currently what we have is directly my app, right? But here we need to add this provider scope. Okay, and that is kind of central to the app. The way Riverpod works is that like, we need to have some scope. Like, if we define a dependency, or if we create an object, right, then for how much time it's accessible, or what's the life cycle of that object, right? That you can define with scope. And here we are basically creating a provider scope. And yeah, inside that we have this my app, and that's it. That allows you to uh, that allows your widget to read any pod or provider that are part of this scope. So if we create one at app level, then we'll have this central scope, that so that we can define some dependency that we want to access in in whole app. So let's do that. Let's wrap our app with provider scope. And yeah, that's the change we have made. And now we'll go to this um, auth phone screen. And we had this auth phone qubit here. And I'll create another file, auth phone pod. Okay. And yeah, we'll actually keep both files for now. Later we'll delete these qubits, just so that we can compare it side by side. So yeah, the first thing we want is that in Riverpod, there are some basics, like you can create a provider this way. Provider is equivalent of qubit. In If you compare Riverpod and block architecture, then like in block architecture we had a string qubit, or like integer qubit that can hold a state of integer, right? Here you can just create a provider of string, and yeah, that will store a string state for you. So yeah, qubit is equal to a provider, kind of like in Riverpod we can have like different type of providers. So uh, yeah, that we'll see later. Today we'll only explore what is needed, just the basics of the Riverpod. So yeah, first thing you'll always need is this scope thing, right? You will need to add the scope, and then you will need to create some providers that you can add in that scope, right? So what I want is, like, if I see the screen, then we'll probably need one provider for this auth phone state, right? And that provider will access it in the screen. So for that we'll need I'll go to getting started, and we'll open the type of providers. And in that, as you can see, you can just create a provider this way. And what we'll need is this state notifier provider. um, you know like, we can create a class this way. And this is our equivalent of qubit, where we define this is our state, okay? And this is a notifier that is basically equivalent of qubit. And we also have similar methods in qubit, right? And those methods just modify the state the same way. So yeah, we'll replace this qubit with this state notifier, okay? And let's import that. And you'll see that almost everything is the same. The only difference is that instead of emit, we have this state is equal to a kind of syntax, okay? And yeah, similar change here. And I think that's it. Only this change is needed. And now if we talk about qubit, right, then we had this type of provider here, okay? And in Riverpod you can actually create that provider here, like final auth phone qubit provider. That is a state note. This is a state notifier, okay? So in order to provide that, we need to create state notifier provider. And inside that also, we similar to what we had here, like, we'll need to provide both this qubit or this like notifier type and the state type. Okay, like same thing here. Now we'll actually rename this qubit to on auth phone notifier. Okay, and yeah, like you can see it's the same thing, right? So if you think about this, then in Riverpod, the state notifier is basically responsible for mutating the state, and we have our state object here, right? So state notifier keeps hold of the state, and it allows us to define some method with which we can actually mutate the state, right? And then we can uh, observe this state auth phone provider in the screen. So these are all the changes that we need in order to replace qubit or like block architecture with the Riverpod. And if I go to screen, then like we don't need this block provider now. Okay, so I remove that, and instead of that, what we really need is like we need to replace our class with something called consumer widget. Okay, and we don't need stateful widget now. The reason is that we are not using the set state method anywhere, right? Because what we have is this Riverpod architecture that allows us to like refresh widgets when needed. And here if you see, then we'll get a second argument in build method. If like we are not extending stateless widget now, right? Instead of that, we are extending consumer widget. So in the consumer widget, there's one build method, and in that we have two parameters that we need to override. So yeah, we have this context and ref. Now this ref is an interesting one, because this is what it will allow us to get access to all the providers that we have created, right? Currently we have only one, but you can have thousands of providers in your app, like one for the repository and all. And ref is what ref is the thing that will allow you to access some provider of a container. So if you don't have a ref, then you cannot access anything from the Riverpod. So yeah, ref we have here, and we'll actually pass it to the body. Okay, and the first thing we need to, like, we'll actually modify this block listener later, but we'll see how actually let me delete this qubit now. So actually we'll start getting some errors. Okay, this block listener, we need to remove it now. I'll add that later. Okay, now let's see what else error we have. So now with qubit, if you remember, then we did two things. Like one thing was like how we can read the state, and another is like how we can call some methods on that notifier or qubit, right? So the same thing is true for Riverpod. Like we'll need two things. One is this notifier that has some methods that we want to invoke on user country selection, and when user types something or they press a button, or when we want to show something based on that value, then we'll need to access its state. Okay, but here if you see, then we have only two instances, and in both the instances we just want to access the method. And earlier we used to read it, get that notifier with context.read, but now as I already mentioned, we'll need to do it with widget ref. So I'll pass it there. Okay, and with ref we have similar kind of method that will allow us to access the notifier, that is ref.read, and then that here is our provider name, and then here dot notifier, that will give us notifier, and on that we have access to all the methods that we have defined, like set country code and set phone number and on submit all. Okay, so this is notifier. Now if you wanted to access state, right, that you can get with ref.read, and then just don't add this notifier. So syntax is really similar for getting both notifier and state, and it's important to understand the difference. State is actual state of the screen where we have variables, right? But notifier is kind of a view model that will that has some methods that will allow us to mutate the state. So here we need only notifier, and yeah, we can get we can call set country code on that, and that will fix the issue. Like we also need to add that widget ref as a parameter here, and yeah, we need to update this method, and we'll need to pass that ref from here as well. Do we have any other error? Yeah, we need similar thing here. Final notifier, and yeah, notifier dot set phone number. Okay, so here at 3 places we have we are accessing the notifier. Okay, but just think about what if we wanted to access the state, right? Like currently we don't need it anywhere, but suppose like whenever user is typing something, we want to just for demonstration we want to update the button text so that that phone number is appended at the end. So we can easily do that, as I mentioned that plus, and then here what we'll need is ref dot watch, and oh, 1 second, I'm not sure. I think it's because of this one I'm getting error. And then we have a phone number here. Okay, and yeah, you can move this inside a string as well with string. So yeah, this should work fine. Let's actually run it and see. First let's see if we have any other error. Yeah, we are not able to find this file, and router yeah, somehow we are not actually I can just call super.key. Okay, and that should fix that router change, because then it's constant. So yeah, when we moved from stateful widget to this consumer widget, we forgot to add the constructor. And now let's try to run this. Okay, and the goal is that if I type something, then it should appear here, and as you can see it works, right? And that's how basically Riverpod works. And if you see, then here we have used ref.read, and here we have used ref.watch. There's a difference between two, and in the main difference is that read will actually read once and then it will not care about updates, but watch will check, like keep checking if there's an updated value, and it will actually refresh the view if there's something that is updated. So yeah, if you are basically observing something in UI, then you should always use watch. But if you are using reference for just getting a notifier that you want to call a method on, then you should use ref.read, and that's what we have done here. And yeah, that should be it. Let's remove this now, because that's not what we want. I'll make it constant, and yeah, I can run this again, and let's see if it works fine. All things will work fine, but as you see, like we are not listening to verification ID change, right? So it will not actually redirect user to the OTP screen. So I'll add phone number, and yeah, if we see, then code sent is called with this token verification ID. So everything is working fine. Now let's see how we can um, observe or listen to changes with in block architecture. We had something like this block listener, right? But that's not what we have in Riverpod. We can use a ref to listen to some provider changes, and I'm not actually sure. I haven't read this Riverpod doc in a while, but what we need to use is ref.listen method, and that will yeah, here it is. Okay, and yeah, that's what we'll need to use. And let's do that. So now we can have here ref.listen. In the provider, we'll need to provide auth found provider, and in the listener we'll get a state. Okay, that will have previous and next values, and yeah, that's it. And what we need to check is if verification ID is not null, then we redirect to this screen. We provide phone number, but as you see, like GitHub Copilot missed thing, and that is we'll need to append the country code here and dial code. It's fine to force unwrap here. And I think that's all we need. Now let's try to run this. This should get called, and yeah, we should get redirected on that other screen. Okay, and let me see if that works. Yeah, it works, right? So I think that's everything that you want to know about basics of the packaging the app, how you should name files, how you should structure your app, and how what is Flutter state management, and how you can do it without any framework, how you can do it with block architecture or block Flutter block, and how you can do it with Riverpod. So the important thing to remember is that depending on your use cases, you might need to use some different providers that we'll see as well as we go on and implement this full app. But the main thing you want to understand is the fundamentals, and that is with this kind of architectures, we'll always have something that manages the state. Then we'll have an actual state, and then that manager will have some functions that will allow us to mutate the state, so that we can go from one state to another. Like when user types something, we call a method on the qubit in case of this Flutter block, and in case of Riverpod, we actually call a method on that notifier to store the updated value of phone number. So there we are basically mutating the state with those notifiers or cubics, and then we'll have updated state. And then all these frameworks will allow us to somehow watch those state changes in the widget, and then yeah, we don't need to worry about that. Whenever the value is changed, our UI will also be updated automatically, and yeah, we'll have separate code for business logic and the actual UI that will allow us to write unit test in future if needed. So yeah, I think that's the summary of the state management and this block architecture and Riverpod. Going forward, yeah, we'll also see lots of different type of providers and those things. We'll keep using Riverpod as that's the one used in the open source repository of the Khelo. But yeah, that's it for today, and yeah, see you in the next episodes. Bye.